Hello everyone. I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU. Good evening to all. Let's start the session. Question number first. A voltage mode PWM control CCM, continuous current control boost converter, has a restrictive closed loop bandwidth and thereby poor dynamic performance. Which of the following statement cannot be a causes of this? Okay, first there exists a RSP pole, right half plane 0. It needs a control to output transfer function. Energy is stored in inductor in first step and then is transferred to the output capacitor in second step. Yes, it is true, but it is had minimum phase characteristic leading to restricted closed loop bandwidth, and last one it has a 0 that add negative phase to the system. To analyze this, first find the transfer function control to output, means output by duty ratio in respect to first of all find the transfer function. Okay, I will start the solving question. The boost converter Vs LC V0 or I0 IC. Apply the condition when switch is on and switch is off. Same as other question. Find after that find the average voltage and the average current of the capacitor, average voltage of the inductor. After that find the small signal losses. After that you solve the equation, then find transfer function, output voltage with respect to the duty ratio. The switch is on, this one on, the loop, this one first loop, current flow like that, the second loop, then find VL, V is here, well, inductor voltage, same as Vs, and current IC is equal to minus I0, this is one opposite of the output current, minus I0, I0 means V0 by R. Second case, the switch is off and the switch is off, then this one off, current flow like that, VL is equal to Vs minus V0, and IC is equal to, this one is IL, you know about that. IC is equal to IL minus I naught. I naught means V naught by R. After that, find the average voltage of the inductor current equation. L diL by dt. Then switch is on, this one dVs. The switch is off, 1 minus d Vs minus V naught. Solve this, dVs plus Vs minus dVs minus 1 minus d V naught. After that, apply the perturbation of the signal, like IL is equal to IL plus IL cap, Vs is equal to Vs plus Vs cap, and D is equal to D plus D cap, and V naught is equal to V cap, average voltage plus perturbation cap. And apply here, then we find L diL cap by dt, little IL divided by dt, diL cap divided by dt, Vs apply, Vs plus Vs cap minus 1 minus d, 1 minus d minus d cap, and V naught plus V naught cap. After solving, find the L di by dt. Vs is the same as the L di by dt, that's cancel out, and find Vs cap minus 1 minus d V naught cap plus d cap V naught. Okay. If you find here Vs, and you know L diL by dt plus 1 minus d V naught cap plus d cap V naught. Question number first. I think this one minus, this one is plus, transfer to the here, so negative. Since apply for the average capacitor current, then we find dVc by dt, and switch is on, V naught by R minus V naught by R minus d V naught by R, plus on switch is off, minus d IL minus V naught by R. Solve this, minus d V naught by R, 1 minus d IL minus V naught by R plus d V naught by R. This one cancel out. Then find dVc by dt, and apply the perturbation of small signal analysis. If you done, find dVc by dt, d is equal to 1 minus d, 1 minus d, d is basically d plus d cap, one minus d IL cap minus d cap IL minus V naught cap by R. You find C dVc cap by dt plus d cap by R plus V naught cap by R. This one question number second. This one question number first. On the basis of question number first and second, find the circuit. Draw a circuit. This one given is Vs equal to L di by dt. It means inductor, some voltage, and this one is the dependent sources. Vs square, this one L, minus dV naught about the C. This one V naught cap. V naught transfer here, then you find the equation is 1 minus dV naught cap. This one is 1 minus d is the turns ratio of this. So IL current transfer here, then you see the current equation. This one and 1 d, this one IL current 1 minus d into IL cap is equal to Vc, this one current, I naught, V naught by R, this one current, and some extra IL current. The dependent source. IL. So for find output right key cap, if you take a two variation circuit with respect to control signal, I think duty ratio, then take a Vs as a 0, it means a constant input voltage. Then if Vs is 0, then this one is short circuited, and remaining is transfer to the secondary side. This one inductor is transferred there, then find 1 minus d whole square to transfer voltage source turn ratio by turn ratio d equal a naught divided by 1 minus d. This one is same. Apply Laplace in this circuit, then find S here, this one here 1 by SC, remaining R portion is same. Then find Vc, the output. V output will take first will take a voltage source, after that take a current source and apply the superposition theorem one by one, then we find first one is d cap V naught divided by 1 minus d. This one output voltage, this one output impedance. If you see here the input impedance, apply this on a open circuit a current source, this one. Then find this one connected in series, apply voltage divider rule, and find R divided by 1 plus SCR. If you solve this parallel circuit, find total impedance by R by 1 plus SCR plus SL divided by 1 minus d whole square, plus when the current source, take the current source, you take the current source, then voltage source is short circuited. Then you find d cap IL, and the parallel circuit into current, like that, 1 plus SCR into SL divided by 1 minus d whole square. So take a V naught divided by d cap, then you solve this, you find taking the IL is equal to 1 minus d, IL is equal to I naught. When the switch is off, then IL same as the I naught average current, I naught is equal to V naught by R, and find IL is equal to V naught by R into 1 minus d, put value here and common V naught by 1 minus d. V naught by 1 minus d is here also, put there, and find SL minus R 1 minus d whole square. So if you solve this, find SL plus R 1 minus d whole square. Here if you observe the control to output transfer function, then find a 0 right hand pole, RSB is right hand plane is present 0. That's why this is known as a non-minimum phase system. Non-minimum phase, because the total phase is reduced. This is say that can add with incorrect option. This one is the minimum phase is given, but this is non-minimum phase. That's why this is incorrect option. Okay, question number 2. The step response to the second order system defined is, this one is the simple transfer function system. You know about the second order transfer function omega square is equal to 2 zeta omega ns omega n plus omega n whole square. Then find omega n is equal to 100, 2 zeta omega n is equal to 50. Find here omega n is equal to 10. Then find zeta is equal to 10, 20, 0.75. So 100 times system. Go to question number 3. Consider the ideal buck converter circuit shown in the figure and assume IL, it means inductor current is the control signal, and no slope compensation, obtain D duty ratio from the current dynamic. Okay, same as the buck converter, same apply for the the switch is on, switch is off, then find the average inductor voltage and annual inductor voltage DIL by dt is equal to, when the switch is on is q into q is equal to 1, q is equal to 1 is Vs, V in, this is on, V in minus V naught, this one first, into D plus 1 minus D, when the switch is off and the q is equal to 0, then we find VL is equal to minus V. Solve this. This one current dynamics, dV in minus dV naught plus V naught plus dV naught, V naught cancel out. Apply the small signal losses, then we find D is equal to D, replace the D by D plus D cap, and V is plus the V in plus V cap, then we find dV in cap plus D cap V in plus V naught cap. Find a D from here. You know about this one is the S, written is S d by L by dt, and L here into IL. dV in D cap V in minus V naught cap, and find D cap here S IL cap minus dV in minus V naught cap divided by dV V in, due to ratio. That is the this one D here, dV in, this one transform there, then find plus V naught. B option is correct. Okay. Question number 4. This question number 4, see, like the buck boost converter, and switch is on, is Q is equal to 1, then Q is equal to 1, then we find this one on, the inductor will charge, and when then Q is equal to 0, then this time this one switch is on and conductor discharge. We also find the open loop input impedance, asking about the input impedance. The same as first of all find the average inductor voltage and average capacitor current. Two equations if you find, then find the all of you solve all of the question also there. All question dependent on the average inductor current and average inductor voltage and average inductor current, sorry, average capacitor current. Apply here average inductor voltage, sorry, and final switch is on, that means Q is equal to 1, Q is equal to 1 means this one circuit, simply connected with V into D plus, and switch is on, Q is off, this one 1 minus D minus V naught. To solve this, we find same as dV in minus 1 minus D V naught. Apply the perturbation. small signal analysis, dl cap, find dt, then we find, I will return directly here because of time not much there, dv dv in minus 1 minus d v naught cap plus d cap v naught. V cap is the V naught cap is the small signal analysis and V naught is the average output voltage. Not confusing them. And then find dV in, written here, rearrange the equation and find L dIL by dt minus d cap V in plus 1 minus d V naught cap minus d cap V naught. You see there you can take a d cap V in and V naught is the same. Bracket 1 minus d V naught. Question number first. Same thing apply here for the capacitor current. Here is capacitor current dVc by dt. When switch is on, Q is equal to 1. And this one is short circuited. This one current flow here, capacitor current flow here like that. V naught by R. This will V naught minus V naught. Then d minus V naught by R. First one Q is equal to 0. That time turn like that. And down this look like that. And one IL minus V naught by R. Solve this. One minus d into IL minus V naught by R. So dV naught by R and dV naught by R cancel out and find this question. Apply it perturbation dVc cap. Then find 1 minus d IL cap plus 2 minus d cap IL VC cap by R. Rearrange this. 1 minus d IL cap is equal to dVc by dt d cap IL Problem question number 1 and second. Draw a circuit. Then you find the circuit like that. See the equation over there. dV in is equal to, this one is a dV in, I think this one cap, dV in cap, this one inductor current, inductor, this one IL, this one dependent source like that, this one minus plus V in minus V naught into D cap. V naught is the 1 minus D, that's why 1 minus D take return ratio. And if you find the inductor current, this is inductor current transfer here, then we find 1 minus d into IL, inverter is equal to VCL. IC current, this one I naught current, V naught is IR. You also will written here by the BC and is not the same, and this one is DIL, other circuit, and DIL. Here ask about the input admittance. Input admittance. Input admittance mean IS, input current divided by input voltage. You find two variation, then you take the D2 is the same because of given here the open loop. In open loop with the duty ratio is 6. The D variation is 0. Okay. After that, transfer the circuit with D is equal to 0. This means this one is a short circuit, this one is a open circuit. D cap is 0, and transfer all the value here. This one are input side. Then we find this one transfer in the Laplace transform, then we find this one SL, and this one 1 by SC, transfer here in the turn ratio of 1 minus d, then we find 1 minus d whole square divided by SC, this one 1 minus d whole square into R. First of all, find V in by dV in by IS. There is the IL. You know about the IS here. When the switch is on, then same IL current flowing through the input side. That's why I have written IS cap is equal to DIL. This one is IL, not IS, and IL is written as IS cap by D. To find the first to find impedance. Impedance means voltage divided by current, and dV in divided by this one IL. IL you connect with the IS. Is into IS cap divided by D is equal to total impedance. This one SL plus this one the parallel circuit R 1 minus D whole square divided by R plus SCR, and D square cancel out. SL into R S square LCR plus R into 1 minus D whole square divided by R is SCR. Here we find D square and find the IS cap divided by V in cap, the admittance, inverse of this, and D putting here, then we find D here, and find this will be T square to R plus SCR. Take one D R 1 minus D whole square common, then find here 1 plus SL divided by 1 minus D whole square plus S square LC divided by 1 minus D whole square. This one is given here ds, and admittance ys is equal to d square r plus SCR divided by r 1 minus d whole square into this one is ds is given in the question. Okay. I think it's B option. So correct. Yeah. After that, question number 5. Is the flyback converter. From the small signal AC equivalence circuit model of the ideal flyback converter, the output impedance is asking for the output impedance. Same question number 2 is over time. I think this one under damp zeta ki value of zeta is 0.75 I think. Find this one omega n square is equal to 100, then we'll find omega n is equal to 10, and 2 zeta omega n is equal to 15 is given, then we'll find zeta is equal to 0.75, the under damped system. Okay. Question number 5, 1.5. The 2 zeta omega n is equal to 15 is given as omega n is equal to 10. That's why zeta is equal to 15 by 20. Omega n is equal to 5. No, omega n is equal to 10. I think omega n square is equal to 100 is given. Same flyback converter also you observe the same, apply the small signal analysis as equivalent circuit, after then find the impedance. Okay, I apply the same formula here when the Q is equal to 1 and Q is equal to half. After that find the average inductor voltage and average inductor current. After that take in the small signal analysis, perturbation of all of the things. After that you find a circuit. If you draw the circuit, then everything is a KVL KCL you can find. Okay, I've solved this. Yeah, Q is equal to 1 when this is on, current flow like that, then this is one VL, same VL is equal to V in, then we find D IL by dt, average I written directly dV in plus when switch is on, this one is equal to 0, this is off, then this energy transfer here, then we find actually given is the dot plot here, this one positive, this one negative, and the output is negative, and n transfer is also given here, turn ratio, then find V naught by N. Same thing apply the small signal analysis. I written directly. Then find dV in plus d cap V in minus you find here and find out minus d not cap by N d cap V naught by N. Take a dV in, rearrange the equation, and dIL by dt minus d cap common, this one d cap common, V in plus V naught by N 1 minus d V naught cap by N. Question number first, same apply for the capacitor current. C dVc by dt. The switch is on here, then this one current not flow here because of this one positive, this one negative, diode is off, this current flow like that, output current means d into minus V naught by R. When the switch is off, transfer here, change the polarity of because of inductor and flow current like that. Then find IC is equal to IL minus V naught by R. IL is actually not IL by N because of the turn ratio. IL by L N minus V naught by R. Always solve this. So then find 1 minus d IL by N minus V naught by R. Apply small signal analysis. Then we find 1 minus d IL cap by N minus d cap IL by N minus V naught cap by R. Don't confuse, this one is the average value of the inductor. You find the IL is written as IL plus IL cap. This one the average value. Rearrange the equation, then we find plus d cap IL by N DC divided by R. This one equation number second. Draw a circuit basis of the equation first and equation second. dV in is equal to this one. That's why I written here. From R, this one C, this one is V naught cap, this one L, this one IL. So this voltage is this voltage V in plus V naught not by R into N. And current equation we transfer here, then we find 1 minus d is the turn ratio of this transformer. Actually the 1 minus d is negative here, negative positive. Okay. Now find here current equation is D cap. This is the positive, so it one there, IL by from this one. Our output impedance, this is output by I naught. Take a D cap is as is 0 and V in its cap is equal to, because of the taken the constant input supply and duty ratio is the fix. Then redraw the circuit. Transfer the inductor and voltage. Voltage is the D is equal to 0. Voltage is equal to 0. That means this one is a short circuit. This one is an open circuit. This one is for written D cap. Here is D cap. D cap is equal to 0. B is 0. And so this one is short circuited. Same like that. This one transfer the secondary side, then we find n is divided by 1 minus d, because of the 1 minus d into d slash n. This one is n, not a 1, because of given here. That's why this is n square. Here inductor current here is 1 minus d divided by n, and capacitor is the same, you know, this is the secondary side, that's why this is not change. And find here Z0. For Z0 you see here they all are connected in the parallel. Solve the parallel circuit and find n square SL divided by 1 minus d whole square parallel 1 by SC parallel R. You know about this one is the R 1 by SC R. You solve this one both and apply for this one, n square SL divided by 1 minus d whole square take a common denominator, then we find someone is the cancel out. I written here one s n square SL or cancel out because I have 1 minus d here common. One R is common here, and 1 minus d I written as d dash in the question is given, that's why d dash square SL by here. So denominator we solve this, then find this one n square SL divided by R. If you R is common, then R cancel out. This one n square S square LCR here, and R also common. That's why R is not here. This is the output impedance. Choose the option. Think D n square L. Yeah. I think D option is correct. Question number 6. For the DC converters on the figure, the right half plane 0, the control to output transfer function will be here given. Find the, ask about the frequency, or what frequency the 0 of the transfer function in right half plane is 0. Right half plane is going to right half plane. What frequency? Or find the transfer function. You know about that. Take inductor voltage, average inductor voltage, and average capacitor current, and after that find the small signal analysis. After that you draw a circuit diagram. If you once draw the circuit diagram, then you find the transfer function. V naught by D. Okay. All of thing is given here. I written directly. This one is the buck boost converter. You know about that. So, and switch is on. So circuit is flowing. Is equal to 1, and directly I written that VIL by dt. And switch is on. This one is a VS. I taken as the VS. This one V naught. I taken L C R. Okay. And it's equal to D VS, and switch is off. Then 1 minus D. This one is, this one can flow like that. This one is a positive, this one negative. This one VL, then VL is connected to here. This one given a positive terminal here. That's why the output also positive. If you, if this one given the positive here, negative here, that's why VL is negative. Either this one positive V naught with respect to the VL. Then taken the small signal analysis and find d Vs cap, d cap Vs plus 1 minus d V naught cap minus d cap V naught. Okay, rearrange this. Same is like another question. Minus Vs V naught cap minus 1 minus d V naught cap. So first same apply for the, this one is equal to 0. The capacitor current dVc by dt. The switch is on. This current flow like that. This one minus V naught by R. D minus V naught by R. And switch is off. This one current flow like that. This one. Then find a minus IL minus V naught by, not IL minus V naught by R. So the minus IL minus V, because the current direction given in the question like that. IL is flow like that. This one is current flow, yes, in this manner. That's why this one is minus IL minus V naught by R. And solve this question. So solve this equation. Then find minus d IL minus, sorry, V naught by R. D V naught by R. This one minus, this one is plus. Cancel out. This one is going to have. And after that apply for the small signal analysis. And find minus 1 minus d into IL cap plus d cap capital IL minus V naught cap divided by R. Rearrange this. Then we find 1 minus d IL cap is equal to minus, so minus 3 comma C dVc by dt d cap IL minus V naught cap by R. So question number 2. On the basis of equation number first and second, draw a circuit diagram. Approx all of the question here solved by the same method. So now this one, so this one given as the dVs. So simplify the dVs cap here. This one IL cap here. This voltage is negative, positive. Vs minus V naught into D cap. This positive here, negative here. This one find 1 minus D. This one take a opposite dot polarity because after this given is a negative terminal here. Then negative terminal. That's why this is given as positive in the question. So take the positive and take the dot polarity is the opposite. That's why this polarity is reverse in primary side. And find the current, and then current for IL here. I will transfer here. The one is the IL, and this one is the minus V naught minus IL. So like that. That's why this one is D cap IL. Now control to output, it means V C divided by D cap. Find, if you find that, then take a Vs is the constant. Then rearrange the circuit once and transfer the Vs is 0 is this one the short circuit. Transfer all the element in the secondary side. That's time by look here. Here is the negative, this one positive, and transfer here the dot product is the negative. That's why this one is the positive. This one is the negative because of the dot product is opposite here. Bs minus B naught to D cap divided by 1 minus D. And here is the SL taken a Laplace 1 minus D whole square. This one is the same D cap IL, then 1 by SC, this one R, and this one is a V naught cap, this one IL cap, 1 minus D IL cap. Take this one is the Z in, this one is the Z output, then find V naught cap. V naught cap is equal to apply same superposition theorem and take a once voltage source. After that take a current source and first take a voltage source, then find its positive negative. Negative here Bs minus B naught 1 minus D cap, and this one connected in the series because this one Z0, this one out open circuit, and this one Z0, this one Z1 both are connected in the series. Then this voltage, output voltage divided by Z total impedance plus when apply current, and so this one is output, this one voltage source is sorted. Then D cap IR is equal to opposite of the impedance and divided by total impedance, the current divided. After that applied multiply your the output impedance is find the output voltage. SL divided by 1 minus d whole square, taken the ZA divided by ZA plus ZA naught into Z naught for the voltage. Then find V naught, D cap both in the common. V cap divided by D cap common, then find Vs minus V naught divided by 1 minus T. Z naught is equal to R plus 1 plus SCR divided by R 1 plus SCR plus SL divided by 1 minus D whole square plus D cap IL. IL same is when switch is on, switch is off. Here the switch is on, this current flow like that. When switch is off, this current flow like that. The switch is off and the flow like that. And the average, if we take an average, the 1 minus D IL is equal to I naught is equal to V naught by R. Actually, this one is the negative I naught because of this one. Current direction is given opposite. That's why take IL is equal to minus V naught by R into 1 minus D. Take this one negative. One minus D find Z in is equal to SL divided by 1 minus D whole square to Z naught or divided by 1 plus SCR R 1 plus SCR plus SL divided by 1 minus D. When this type of polarity, this one is to take average voltage 0 in this. For find the output voltage, then take a 0 this one, because of the average inductor voltage is 0 in voltage balance second balance equation. Then here the find the V naught is equal to minus dVs divided by 1 minus D, take a Vs, and the Vs is equal to minus V naught 1 minus D divided by D. And if you take here, put the value of V naught in the both sides, this one, and find Vs minus 1 plus and dVs divided by 1 minus D to R 1 minus D whole square divided by R 1 minus D whole square plus SL take a minus is the plus, so take a Vs, this one D common, and dVs divided by R into 1 minus D whole square and R into SLR divided by R 1 minus D whole square plus SL plus S square LCR. Take this one is the K for easy solution. You take the here common 1 minus D, then find on dVs is cancelled out, only Vs is present here and Vs is present here, then take a common Vs by 1 minus d the whole square. Then 1 minus d whole square. This one also present here, whole square. This one the r. So minus going inside. Whole square plus this one d present here. Vs common. D into S and R divided by K. The common. Take a D L into R is a common, then find Vs divided by 1 minus d whole square into D. Then this one R is concealed out here. Because of R here, then R will cancel out, only this is DL is a common, then find S minus R 1 minus d whole square divided by DL. This is the zero of this transfer function. This is the pole is given here, and it's given the zero for frequency. Then we find a frequency. This one is the counter frequency R 1 minus d whole square dl, and zero frequency 0. Then put all the value. R is given at 10, d is equal to 0.6, n is equal to 160 microhenry. I think. Put other value and solve this, and find 60.7 kilowatts. The answer. It is asking about the zero, right hand pole 0. Right. This one, the corner frequency. Question number 7 here. Control to output transfer function of the converter shown in the figure. In this one, I find the output analytical expression of K. Here the given the value, all of data. Okay. Duty ratio is given. Then circuit is the boost converter. You know about that. And this is the not a ideal boost converter. This one is the practical boost converter because of given the R, inductor current, inductor resistance. Same thing here, apply same, taking the average voltage of inductor and average current of inductor. After this, take the small signal losses, then we find the transfer function. Here actually I ask about the VC controlled output. This means VC divided by IL, IC, the current of the inductor current, taking the control input. First of all, same draw the ones Q is equal to 1, Q is equal to 1, then DIL, CL, LD, IL by dt. When switch is on, then find this loop. In this loop, you taking d V in minus IL into R, and dV in minus d IL into RL plus 1 minus t. The switch is off, and this one on, then the current like that. Then same, find Vs, V in minus V naught minus IL into RL. To solve this, some term is cancelled out, and find V in, dV in cancel mass load, and V in multiply by 1 V here IL into RL minus the V naught. Taking the small signal and losses, so this is not a small signal. Find V in cap minus IL cap into RL. So find 1 minus D V naught cap D cap V naught. Question number first. Find here D cap V naught here. Then we find L DIL by dt. Can also written L DIL by dt as SL into IL minus V. Okay. Take equation of the capacitor current, and switch is on, then current flow like that, opposites, and minus V naught by R, then minus D V naught by R, 1 minus D current flow IL minus V naught by R. To solve this directly, this only written I have written directly the small signal losses, and find 1 minus D IL cap minus D cap IL V naught cap by R. So V naught D V naught cancel out, only V naught by R is present here. We will solve this, and after that taking that. Question number second, question number, this one is first, this one is second. To control the output given on the one is a pole, one is a 0. VC by AL, take V is a constant, this small signal is 0 up to input voltage. So small signal 0, this means this one is a 0, and take a Laplace of this. Question number first. SL IL cap is equal to minus IL cap into RL minus 1 minus D cap D cap V naught, find D cap V naught here, find SL plus RL to IL cap. And question number third. From question number second, same चीज apply करके Laplace SC into VC cap 1 minus D IL cap D cap IL. So VC is the same as V naught, it has V naught by R. D cap IL is here, then we find 1 minus D IL cap, this one IL cap, minus SC here, SC plus R, then we find 1 R plus 1 plus SCR divided by R into V naught cap. This one number 4. Equation number 3 divided by equation number 4 and find real by IL. You can also take a IL is equal to same as you find here IL V naught by R, V naught by R into 1 minus T. With the boost converter, IL into 1 minus D is equal to I naught is equal to V naught by R, and IL is equal to V naught by R into 1 minus D. So this one the average, actually average is inductor current, that's why I taken V naught by R to 1 minus D. If you divide this equation, then V naught cancel out, R into 1 minus D to the upper side, SL plus S RL into IL cap minus 1 plus SCR 1 minus D into BC. Multiply both to find 1 minus D whole square IL cap minus R into 1 minus D 1 plus SCR divided by R into V naught cap is equal to SL plus RL IL cap 1 minus D V naught cap. Take a V naught in one side and IL is the another side. Then find one minus D minus R 1 minus D 1 plus SCR V naught cap. This one is a positive. I will take this. I think this one is the positive. DV naught is the positive. Minus here the SL plus R minus R 1 minus D whole square the IL cap. If you solve this, then you find VL naught cap L cap is equal to, I have written indirectly here, R 1 minus D whole square minus RL minus SL here multiply by this negative, find negative, negative here, then this one negative, this one negative, this one positive. That's why these are here, and denominator take 1 minus d is common, then find 2 plus SCR. Take this one is the common here from the denominator and 2 common from the denominator. R1 minus d whole square minus Rn divided by 2, 1 minus d. Take here, then find 1 minus Sn divided by R1 minus d whole square minus Rn 1 plus SCR divided by 2. Then minus the omega p, omega z and k 1 by omega p is equal to RC divided by 2. That's why omega p 2 by RC and 1 by omega z and z. So L divided by R 1 minus d whole square minus RL. That's why omega z is equal to omega d whole square minus RL divided by L. K is the remaining thing. Okay. R 1 minus d whole square minus Rm divided by 2 1 minus d from here. I think D option is correct. Okay everyone, I stop here. Thanks to all. I put a link